In this video, we're solving a max fruit problem. Basically, the question is that you have this input of different fruits. So you have apple, bananas, oranges, but you only have two baskets. And in this two basket, you can only put one kind of fruit, but you can put as many as you want. So this is a classic sliding window problem. Um, so if you look at the input, you can see that if we want, we can get apple, banana, or banana orange, or orange apple. And then if you get to the last one, then you'll get one more apple. Then we're happy, so which means the output would be 3 with one orange and 2 apples. And basically the brute force way of doing it is to get all the subarrays. All the subarray, which means you have to sort this thing, so it can be as, at the worst case scenario, it can get to as worse as the big O of n permutation thing. But inside of brute force, we use this sliding window, which is something that's more easier. And the way it works is basically you put pointers left and you put this array like 0. I will just abbreviate all the letters with A, B, O, A. And we have a red pointer which goes to the right. And the constraints are that you can only have 2 kinds of fruits only, which means that you can get a bucket to represent those constraints. So let's write down the pseudo code here. So before we do that, we do want to consider other constraints too, or like there's another way that you approach this thing is, so say if you get the array from the right, and you would want this to deduct the ones from the left, because the ones from the left never mind. This is another problem. No, so you want the max fruit, basically. Yes. Which is like the max between things. Yeah, we'll go into details later, but let's write the pseudocode first, which is, well, first of all, you need a loop where you can loop through the whole list, or loop in range, basically. And the next thing you do is you check the edge cases where this thing happens. Two kinds of fruits only, so you go to here, sorry, like the left pointer goes to A, but then the right pointer goes to orange, which means you have to break this pattern. So the way to break it is we lay out the condition first. So if the length in this bucket is equals to 2, this is the length, and you go over one more, and you find that the right pointer is not inside of the existing bucket, that's where you get panicked. No, you're not panicking, but you just drop, you have to make decisions. So not in bucket. And the decision you make is that, well, an easy way is, or the way to go is you push this left pointer to the right. So you can either, so there are two approaches. You can just delete, or you have to move the left one, basically one more, and then you basically delete this L minus 1, like the ones before, like the apple, drop the apple, which is also the same way as if you do like, you let L go to one more, if you go let L go into one more, then okay, I'm a little bit zoomed out, but yeah, I know how this one goes. Basically, you reset everything, if that's the word. Reset. So in this array of L, you can reset R back here. So reset L equals 0. Of course, you have to have like this initial values here, like L R equals to 0 and max fruit equals blah blah, and you reset L and R to 0, and also the bucket, just clean everything and reset everything. And we start over, and here's what over means, which is the else part. Like normally, if you just go like on a okay, there's one more thing that you keep forgetting, but you need to learn, which is to count the maximum thing. You have to count the max fruit, which is basically, now I can write it down, max of the max fruit with the bucket value, bucket dot values, and else you will need to get this L going on, no, mostly R. Else you just add up this R, and before you do that, you want the bucket to be filled in too. So you put the bucket value, update it to like, if there's one more thing, then you put it inside. So you update one more, just add one more to it, and then add up R, and then also you might need to update your max fruit here, and finally just return the max fruit. Okay, so this is a pseudocode, and I'm gonna make the real code in the next video. And in terms of the time complexity, as you can see from here, if you're moving like there's 2 pointers, but like you go through each one of the items in this list, so it should be the big O in the order of n, like linear. And in terms of space, all you need is the bucket, and the bucket only drops to 2, so the bucket would be just a constant value. Okay, let's see you